All right.
All right, welcome back, everybody. This is the 2025 Virtual Residency Workshop. It's our 11th annual. It is Thursday, June 26th, 2025, and this is our fourth session of the day. This is a panel on assessing and anticipating researcher needs. Our moderator is Eduardo Colmenares, and I'm going to turn the show over to Eduardo to introduce the panelists and take it away.
Sure. Thank you, Henry. Thank you so much. First of all, thank you so much to everybody for being here. We're going to have a very nice, interesting panel in which we're going to analyze the needs that researchers and staff are going to have and many of the compromises that we have to go through when designing high-performance computing systems. So allow me to introduce myself, and then we will go around. My name is Eduardo Colmenares, faculty member in Midwestern State University, a small university very close to the border with Oklahoma. Uh, I'm going to pass it around, so I'm going to go with Alice. Alice.
Hello, my name is Alex Townsend. I'm an application specialist and research computing facilitator at the Research Computing Center in Florida at Florida State University. And my background is in computational science and data
Great,
science.
great. Thank you so much. David.
Hey, David Lockett, Meharry Medical College, School of Applied Computational Sciences. We focus and offer programs in data science, computer science, AI, cybersecurity, and bioinformatics. I currently serve as a co-principal investigator on a variety of projects, as well as grants development specialist for the university.
All right. Thank you so much. Nice to have you. Nicholas.
Hi, everyone. My name is Nicholas Daines. I am a computational scientist at Colorado School of Mines, working in the research computing group. In practice, that means I do a combination of application support and research facilitation. My background is also in computational applied mathematics.
Great. Clinton.
Thank you, Eduardo. My name's
Sure.
Hyder, and I work for Rice University's Center for Research Computing. I'm the manager of our facilitation and data visualization team. And my background has mostly been supporting infrastructure and networking, storage, and compute on Linux and Unix platforms. Have more of an emphasis on user support, training, and facilitation. Thanks.
All right. Troy.
Hi, everyone. My name's Troy Bear. I'm with the Ohio Supercomputer Center, and I am the HPC operations manager there. But in a previous life and at previous centers, I have done user support as well as code tuning and a little bit of everything. So hope to have a good discussion today.
All right. Great. All righty. Now that we know the panelists, let's go ahead and go for some very nice questions that will give us a lot of very nice, interesting information. One of the possible questions that we have is as follows. How do you handle users who have used the same workflow for years or decades if they are unwilling to update said workflow? Can we meet these users halfway? What is your experience with this type of situations? Alex, would you like to go first?
Am I still muted or can you hear me?
We
We
can
can
hear
hear
you.
you.
Okay, cool. My Zoom was just taking a couple minutes to respond. So this question comes up because I've had a couple of users that have been using the same workflow for decades and decades. A couple of months ago, I had a researcher come to me who was using a coupled ocean atmosphere model, and the coupled ocean atmosphere model had two components, and those components they were both very old from the early 2000s, and there was glue code that was from the 1980s. In fact, it
Mm.
was so old that when I tried to compile, it only compiled with the Intel compilers, and when it compiled, it threw the Y2K warning. So what we've tried to do, so we have tried to, my whole philosophy with this has been to try to meet the user halfway, do what we can, try to compile it as much as we can. We were lucky in this case in that the model still compiles with the with our current Intel 2021 compilers. Doesn't work with anything else. But in general, uh, was it CESM? No, actually, it was RSM and ROMs. So in general, my philosophy has always been try to meet the user halfway, try to get them as far as we can with their current workflow. But we ended up running into just a block with some of this code. So we're trying to help. I'm currently working to try to figure out what pieces exactly need modernized and trying to modernize as little as possible so that we don't break the workflow. Have you all had any other experience with that? And if so, what
So,
have you done?
Yes, Troy, go ahead.
so we went through this a few years ago when we went through a transition from a Torque Moab system that we'd been using for almost 20 years at that point to Slurm. And the directive changes that were required for that were fairly intensive, and people had to think about things a little differently. And one of the things that we did was we installed the torque compatibility layer for Slurm, and we kept that around on all of the systems that had been in existence when we did the transition. But we've been slowly, as we roll those systems off and we roll new systems in, we've been deprecating those tools, and now we've actually stopped installing them. And people will write in occasionally and say, "Where was this?" Well, okay, here's our documentation on on how to move things. And it's just, people sometimes people don't want to move until they have to move. But sometimes people will also, especially if they can see that things are clear or things work better, sometimes they'll move on their own. So it really depends.
All right. Clinton, have you had
I
that? Yeah, go ahead.
oh, I didn't mean to interrupt. Quentin, if you want to go before me.
Oh, no, 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 that's fine. Clinton, do you have something on for this question?
Yeah, I mean, I think this is, that's a problem I've seen in a few different situations. Sometimes it's with, with commercial software packages as well that have been essentially abandoned by by the company. And so, I mean, we've tried a few different approaches, like even like, virtualization and like sort of trying to keep the application within a container because of updates and other things. But, one of the approaches is just to try to explain the risk as best as you can to the researcher. And and some of it depends on sort of how long term they're but yeah, if you're talking about somebody who's doing the same workflow for decades, it's going to be hard to dislodge that. If it's a lot of times it's a graduate student who has like a very short term need to just get through, and run their code and get finished. And so, they don't have as much of a commitment to like trying to bring it forward or modernize it. But yeah, trying to explain the risks and just the limitations of, is part of our job, so that they at least understand that they may end up being unable to do anything at all at some point if the underlying systems fail or become unavailable. So
Nicholas?
Yeah, just another couple examples. So
Sure.
one example was last year we upgraded from CentOS 7 to Rocky Linux 9 on our systems, and one of the things that we didn't anticipate was the native GCC compiler support on the OS. They bumped all the way up to version 11, and there were researchers who were still needing codes that ran version 7, version 9. So in order to meet those users halfway, our approach has always just been to containerize things, and that seems to be a good happy medium. They have to kind of learn a new way of launching their jobs, but for the most part, as long as I kind of just give them what they need to change, they're pretty happy with it. And then the second example, this is kind of ties into the previous session about cloud compute, is that we have a pilot going on at Google Cloud, and some of the researchers have HPC backgrounds, and they don't want to learn, some new Google batch, product to do their work. So the thing we do to kind of meet them halfway is that set up a certain cluster in GCP, and then just that is something that's familiar to them, so they don't have to learn too many things new.
Okay. David?
One thing that we've looked at is, what about incremental updates? You want to improve the overall, security, the compatibility, but what about offering, small incremental updates, to, update, the critical parts of not only the workflow, but, you're allowing, your faculty and staff to kind of retain those familiar processes. So incremental updates is, something that we've looked at before.
All right. Well, thank you so much. I'm going to go with the next question, and it goes as follows. What are the key trade-offs when designing scalable high-performance computing systems? For example, performance versus energy, energy versus cost. What have you observed based on your personal experiences? Any volunteer?
It really comes down to budget,
Right.
especially
Budget.
with power. The wag that I heard a few years ago was that a megawatt of power is about $1 million to install and about $1 million a year to pay the ongoing costs. So there is a trade-off there that you want to be as power efficient as possible. But on the other hand, we've also observed where if you try to turn on some of the power saving features on modern servers, they will either perform very badly or they don't do anything. So it really does require an investment of staff time to figure out what the best trade-offs are there. And some of the batch systems now have a thing where they can turn your nodes off if they're idle and turn them back on when demand ramps up. But again, it's just a question of, how much staff time do you have to spend on it? How much are you willing to tolerate as far as performance variation? And how much are you willing to pay for your power bill?
All right. David?
Yeah, I spend part of my time, writing grants and, looking for federal funding. And I say, balancing budgets, is a constant challenge, but you've got to look at constraints, with what the university is needing for future growth. When you look at, things like cost versus scalability, you have to, look at the, how can we increase the initial and the ongoing costs? How can we, how can we integrate, advanced infrastructure? How can we look at the software licensing? So, you have to look at that cost versus scalability scenario, and I'm hearing that in a lot of our questions.
All right. Clinton?
Just thinking about the question and some of the different trade-offs. I mean, one of the things that I've noticed is that we're seeing at least in our installations, larger nodes and fewer nodes in our HPC environment, which has some impact on both sort of power consumption and space consumption, floor space consumption. But it also tends to concentrate more, and like I think about, some of our older clusters where we had lots and lots of nodes, you lose a node, it's not that big of a deal. So maybe you don't put as much redundancy and that kind of thing in the design. And in these larger node clusters that you know, you lose a node, it's a pretty big deal. So it's kind of interesting to me to see how it's like node sizes play into how you spec the nodes. Obviously with GPUs, in consideration. So we have heterogeneous cluster design. So we have sort of one big cluster with a bunch of different node specs inside of it as a way of running. I'm sure a lot of centers do that. And we have older nodes, that are still working, and we keep them running for as long as we can, and then add new nodes in and slowly phase the old ones out, so we get as much life out of the hardware as we can. We operate our own data center, so that is to some extent a bit of a savings for us in the sense, from at least from the researcher's point of view, because the cost model doesn't reflect the data center costs. That's sort of taken care of by the university's infrastructure. So, but that's one of the interesting things to me is how do you decide sort of node sizes and densities, and factor that into your kind of management how you manage the hardware and how you make space for it.
All right. Thank you, Clinton. Alex?
So for the most part, we do a lot. We do a lot of the same things that Clinton's group does. We have a single HPC cluster, and we incrementally add new nodes over time. That tends to make the most sense. I know of other institutions around that tend to do whole cluster refreshes over time. That's just not cost effective for us. So we try to keep our nodes running for as long as humanly possible. I mean, we've still got some compute nodes running from 2012. I think we had some 2010s and 2008s until very recently, and we just turned them off. But we like to try to keep things running for as long as possible. Um, for energy efficiency, we recently switched to adding water-cooled nodes because the core density was just so much that we really couldn't afford to keep trying to upgrade the air cooling system.
All right. Nicholas?
Yeah, so I'm going to speak from the perspective of a smaller institution. We
Sure.
have two pretty small HPC clusters on premise. One of them is about over 10 years old. So one of the things we're challenged with is finding the trade-off of how much longer do we keep this thing running, but it's taking up a third of our power capacity. So that's something we always have to balance on top of institutional direction in looking into moving towards the cloud, so we don't have that burden of power and data center needs. And then at the same time, there are obviously now other researchers who are going to be running 24/7, and they can't afford to run in the cloud. So you still want to keep that on-premise solution for those use cases. So this is something we're dealing with now. I don't have a direct answer for it. So if people have
It's okay.
their own experiences, so great to hear. So
No problem. Feedback, every case is different. Every institution has different
yeah.
needs, so it's a valid point of view. All right, let's move on to the next question. So the question goes as follows. Well, we know that there is a big difference between need and what we want. We have seen that so many times. So when talking to researchers, what approach do you find work the best to get a clear understanding of their needs versus what they want? Troy, would you like to go first?
Yeah, I can. So the thing that I found that works the best is let the researcher describe what they're trying to do, and they're probably going to give you a very specific technical solution that they think is what they want to do. And then when they're done with that, you ask them, okay, now what are you actually trying to do? Because getting them to speak in more general terms about what they're trying to do will open up more possibilities for solutions that they, or maybe even you, haven't thought of. It's the difference between the customer coming to you and saying, well, I need to run Microsoft Word versus I need to write a document. And getting them to the I need to write a document part of the conversation is really key. There was a session yesterday talking about intake interviews that was really, I thought was really great, about talking about how to frame things in a way to get the researcher to think about more general approaches than what the solution that they may have already engineered that may or may not work on your system depending on how it's structured.
All right. David, would you like to go next?
Yeah, Troy had some very good points. A lot of times, when we're talking to faculty and staff and researchers, I always like to I just start with probing questions, and I'm listening, I'm actively listening. I try to ask opening questions. I try to follow up. I always like to distinguish what is actually essential and what is preferred. Because a lot of times you're going to hear what's preferred over what's essential. Another thing we like to do too is observe. Look at the the workflow that's going with that faculty, that staff member. Try to identify any actual points, any kind of requirements as far as their needs that are concerned.
All right. Alex?
I would second pretty much everything that's been said so far. Whenever I go in addressing new, trying to assess what a researcher needs, most of the time I will pretty much always go in with a listening attitude. I try to get a feel for what they need. I try to get an idea of what their actual project is and what the workflow they're going to be doing is. Um, I try to modify their workflow as little as possible because one of the things that I see a lot of is that most of the time when they're coming to us, they're coming to us from a laptop where they already have a workflow established. So my goal is to try to make it as easy as possible for them to transition from the laptop to the HPC system. So listen as much as I can, try to keep things the same as much as I can, and just
All
go
right.
from there.
Clinton or Nicholas, anything would you like to add?
Just to give one more perspective, sometimes I get researchers who will, set up a meeting with me, and they're not really sure what they want. They have a general sense of what they need, maybe something like, I need my code to run faster. I need a lot of storage. So boiling down what those questions mean, and then from there, usually what I like to do is give them a general overview of what is relevant to them that we provide. So that could be anything from a on-site storage solution, on-premise HPC, or even recommending, off-premise HPC through access if we don't have the hardware that they need. So that's what I would add.
Yeah, no, I think I would add a couple of other things that in
Sure.
my experience would be, and again, it kind of depends on who you're working with. That the field of research makes a big difference in many cases because you have some researchers who are very technical that are from, engineering or computer science fields, and then you have others who are not as technically inclined. And so, but I agree with everything that everybody else said that, it starts with listening and having them describe their research and their workflows, get into the problem that they are interested specifically in solving. But a few things that I look for as a facilitator are other opportunities to help in other areas of their research. So sometimes I like to kind of get a more broad picture of what they're doing. And the other point I always make is like in many cases, especially with newer faculty, uh, to encourage them to not over engineer, and for their eyes to not get too big, when they start to think about all the resources they need. Starts relatively small, make sure that the applications and workflows are working before you try to scale them out, because the most difficult part is getting all the different software and components to talk to each other. And then once you get that working, then it's a lot easier to scale up. So those are some things that I've experienced in my roles.
Well, thank you so much to everybody. That question was from the point of view that the researcher comes to you today saying, hey, this is what we want. And then you have to identify what they want versus what they need. Now, the following question is kind of related to that, but it's slightly different. And it goes as follows. What are some ways you have used to try to anticipate so that you haven't met the researcher, but you are going to go ahead of the curve and you are going to anticipate those needs? So what are some of the ways that you have used to try to anticipate researcher needs? Troy, would you like to go first?
Sorry, I was muted there.
It's okay.
So one of the things that we do is to watch our ticket system for trends in requests. Because what will happen is a bunch of researchers will go to a conference, they'll hear about something, they'll want to try it out, and there will be a bunch of requests at roughly the same time for, well, I want to do X or I want to try X software. And to kind of paraphrase Ian Fleming, uh, once is happenstance, twice is coincidence, three times is a new service offering.
All righty. That's a very nice one. David?
We look at we look at trend analysis. We look across the board to see what is what's actually being adopted at different universities. We're always trying to be proactive and prepare for new requirements. We actively monitor trends in funding, federal funding, trends in research, and ongoing trends in technology. Something that we're also integrating to is kind of a regular feedback loop, and within that regular feedback loop, you're looking at user experience, user forums, help desk tickets. You're trying to spot any type of emerging needs, so you can in turn anticipate what the researcher, is asking for, what the research is needing. So it kind of comes back all together.
All right. Alex.
Yeah, that's pretty much exactly what we do. We do a lot. We do a lot. We do a little bit of trend analysis. We're a small team here at FSU, so it's fairly informal, more like I notice we get a lot of these kinds of tickets. Maybe we should look at that. Maybe we should look at doing something about that. Or one thing that happens is if we start getting the same ticket over and over and over again, we'll start looking at saying, okay, we keep getting people to ask the same we keep getting people asking for the same piece of software over and over and over again. Maybe instead of going and doing home directory installations, we should do a central installation. We had this come up with Rely On. We had actually very recently we had it come up with CryoSpark. That was loads of fun. But um, that's pretty much what we do. We look for what kinds of recurring things have come up in our tickets. Um, Also, we kind of keep it. We try to keep an eye out on what's going on in the vendor space too. For example, if Anaconda decides to be problematic, we start looking at alternative package managers. Um, Sometimes our researchers give us really good ideas too. For example, with package Python package managers, I had a one of our researchers introduced me to a new Python package manager called UV, and I first tried it and I have not looked back. I haven't used pip ever. I haven't used pip since. It's just that good. So
All right.
sometimes you get really good ideas. Sometimes listen to the researchers too, man. They sometimes they have some really good ideas and they'll give you some good things to centrally host.
Thank you so much. That's a good one. I took note of that one. Clinton, would you like to add something?
I think one other way is just, community participation, see what your peers and and at obviously at conferences like peer conference and things like that, just kind of get an idea of what the temperature is on different areas of research, different sort of challenges that people are coming up against. Um, and we also we look at the types of jobs and that people are running on the systems, as others have mentioned. Like one trend recently, it's probably for a variety of different reasons, is we're seeing fewer and fewer MPI jobs and more like S&P type jobs and that type of, or just, just fully parallel jobs with no synchronization. So it's kind of interesting to see that shift. Not sure entirely what's behind it, but we'll see different types of requests for different types of workloads that then feed into decisions that we make about what kind of expansions we plan to do with our hardware and what kind of things we want to get into. And so those are the things that I think we've looked at least in the HPC space, anticipating things because we do a lot of support outside of just HPC in our group as well. That's a little harder to do. A lot of that tech moves really fast, and there's a lot of it. So yeah, it's challenging.
All right. Thank you, Clinton. Nicholas, would you like to add something?
Yeah, the things that I'd like to add is one is to build out documentation on your websites, whether it's intranet or on the internet, about what solutions you have for computing. So we worked with our marketing team to help, build out what resources we have, whether it's HPC, cloud, storage. So then when they are looking for compute, they can have at least a first spot to look and see what we offer. And then the other thing I'd like to add is just like kind of all the little minutia to make sure researchers feel like they're being taken care of quickly. So things like making processes to provision accounts, whether that's for HPC or storage. So we've recently started building out, SOPs for that from the IT world, so that if one of us are out, there's a whole process, that'll make their account quickly, right? So then they're not waiting for their account. So, yeah.
All right. All right. Thank you so much. So the next question goes as follows. How do you balance researcher needs versus staff availability slash workload? Clinton, would you like to go first?
Boy.
Yeah, could you, or somebody else? It's fine.
Oh,
I'm just trying to go around the board, different order, giving everybody
Yeah,
first
yeah, yeah.
opportunity for second.
No, I think that's a really, it's a tough question. I think that um one of the things that we try to do as much as we can is set expectations with our user community about, the availability of our staff. Our shop, at least at present time, is not a 24/7 operation, right? So we in the culture, our culture here is fairly laid back. And so you get a sense that when researchers ask for things, sometimes, a faculty member will ask for something and they expect a response right away. Other times it's like, get to this when you have time. So there is a little bit of kind of negotiation that goes on. In general, like I said, I think our culture is pretty supportive of our staff, and they understand our limitations. I think maybe what's a harder conversation than sort of staff hours is sort of saying that you don't have the capacity to meet a particular need in terms of infrastructure, right? Or tools or tooling or whatever. I think that might actually be a tougher thing to explain. But you know, I think one of the things we also have tried to do, because our group does a fair amount of support of faculty-owned hardware, which can be very, very burdensome in terms of time and effort because it's so heterogeneous. And we are making efforts to try to offset that as much as we can to encourage the use of our shared core resources and to embrace standardization of those types of systems as much as possible. Those are any process that we can automate. We're in the process of trying to implement cold front, maybe some more self-service options for some of our users. So those are some things that we're looking at. But yeah, it's tough.
Okay. Thank you, Clinton. Troy, would you like to add something?
Yeah. So one of the things that we've seen with this is one-offs are really hard to support. If you've got something where somebody wants a completely custom solution for a particular problem, there's a limit to how many of those you can do. So we really do try to look for, is there a way to do this in such a way that we can reuse as much of it as possible the next time somebody comes along and asks for something similar. Because you can do one-offs, but you can't do too many one-offs because if they're unique, then there's no economy of scale in supporting them.
All right. Thank you so much. Nicholas?
Yeah, I think one of the things is try to over communicate with the researcher if you are busy, that you don't want to leave them hanging if they ask you for example, a one-off request and either you're busy or it's a really hard problem so you can't figure it out. And then the other thing I would add also is that at least for me, sometimes I have a little bit of stubbornness to resolving a problem for a researcher, and I don't look for external help, whether that's the developer or a service contract. If those resources are available, ask sooner than you think, because then that can help take off some of the load to you.
All right. Um, David or Alex, you want to add something?
Yeah, I can add one or two just quick points. Communication is always important and a must. Make sure there's transparent communication. You're clearly setting, timelines. You're setting realistic expectations for, whatever constraints might be in place. One thing that we also, prioritize is, looking at the framework. Prioritize requests based on impact and urgency. This can, kind of, more or less kind of help you balance that workload by prioritizing the framework.
All right.
Yeah, I will second everything Nicholas said. I am very bad about falling on my sword to get things done, to get researcher to meet researcher needs. And I hate saying we just can't do that, but sometimes you have to. One thing that I will mention that we implemented here at FSU, and this is entirely thanks to the software my manager, the software team manager, Marcelina Nogales. She implemented it's a DocuSign form. So for big projects that are going to be really intent, that are going to be more than just a simple installation, what she implemented and what we'll do now is we'll have a meeting with the user. We'll write down what they want and what they need, and then we'll work with them to come up with a list of things that we can do versus what they need, and then we'll send them a document to sign saying this is precisely what you will get from us. And we will also include in that list of things like this is what you asked for this, but we can't do this, and here's why. And we ask them to sign it before we proceed with the project. We especially like to do this for paid projects.
Right.
This helps a lot because we've had a number before we did this, we had a number of experiences where the list of needs would grow every 2 weeks.
All right. Well, thank you so much. I saw something interesting here on the chat, and since the purpose of this is also to reach out to the community and help them with their questions or inquiries. There was one about change for more details for CryoSpark configuration, for example, the use of virtual machine or not, the installation or dependent libraries. I saw that you, Alice, you provided an answer. Would you like to expand a little bit more and lead the answer?
Of course. So with CryoSpark here at FSU, it's actually been pretty recent over the course of the last 2 years. We've gotten a number of new biomedical science faculty who've started to do cryo-electron microscopy research, and it seems like CryoSpark has kind of become the quote unquote new hotness in cryo-EM research. So they used to be Relion and other software, but now it's CryoSpark, and after installing it, I can kind of see why. It's a point and click web interface. You don't have to do much in the way of command line stuff. So when we first when we first started installing it, the way we would do it is we would ask the user to acquire a CryoSpark license ID and then send us the license ID. What we would do from then is it was usually me. I would go in to their home directory, download and I would run the installation step by step as they said as they detailed in the installation instructions. Um, One thing I would do for cases where there's going to be multiple users on the same node is I would make sure that no two users within the same group um, had the same port ID. So CryoSpark's web UI runs on localhost with a specific port. I think it defaults to 69,000, but I would make sure to, or 39,000, but I'd make sure to set it differently for each individual user. We'd do the initial setup, we'd give them the initial login, and then they'd go from there. And when they broke the database 2 weeks later, I'd get an email saying help. So, um,
All right.
that was the local version. We also do the cluster version. The cluster version we stood up a couple of months ago and still very much in beta testing. That has a head node running on a virtual machine where we installed just the master process. That's installed locally, not on our parallel storage. And I personally love the cluster version because it makes setting up because you can actually set up lanes as just a simple Slurm script, and you don't actually have to run the worker setup on the GPU node. It just kind of, as long as it knows where to find the worker process, it's good to go, and it's great.
All right.
Um, but there is a security problem with the cluster version, and that's that the CryoSpark cluster version requires that the master process a run under one user called CryoSpark user. That means that CryoSpark user has to have access to every user's data. So in theory, two users could get access to each other's data if they knew where it was. And for this reason, we offer both versions. If they are okay with that risk, they can have the cluster version. If they really can't afford it, we give them the single workstation.
All right. Anybody else wants to comment on it, or we can move on to the next question?
So
Hit
It's the first time I've heard of it.
All right, yeah, that's fine. That's the reason why I asked. No problem. No
the
problem at all.
the
But
so
good.
the
Yes, go
the
ahead. Go ahead, Troy.
so we've done that, and what we've done is we have a separate instance of the cluster application for each project, and it runs as a community account inside that project. So it doesn't give complete containment, but the assumption is, well, everybody that has access to this is on the same project. They're collaborating anyway, so it's up to them to manage who has access to what data. But the it is tough to scale that out, and I don't think, at least I haven't seen anybody who's come up with a good containerized way to run CryoSpark yet. At least not the cluster version of it.
All right. All right, Troy, thank you so much for that feedback. So we're going to move to the next question, and it goes as follows. What are some strategies for serving less technical end users or interactive users? Specifically, how do we balance on-demand access needs with traditional queue-based scheduling? Clinton, would you like to go first?
Well, yeah, I think that in our case, we're still in the process of trying to implement open on demand, and we have, for example, a debug queue in our Slurm uh, configuration, but it's not necessarily a true interactive experience. So for people who don't have the command line um, comfort, they're not comfortable with SSH and doing things at the command line, that still doesn't really get them anywhere. So one of the things that I think we're we're trying to figure out is how do we provide those quick interactive, and specifically in the case of open on demand, how do we provide that interactive experience without, and where people get the resources right away without compromising the total capacity of the system. The way we at least have it right now is we have some separate nodes set aside for a particular partition that our open on demand users will be utilizing, kind of like a reservation. But I don't know how other centers are doing that, and I'm kind of curious to know, what the different strategies are. I've heard some centers just let everybody just go in and run, and maybe they have enough capacity, but if you launch an open on demand session and come back after lunch and you still don't have a window, then it's not on demand, right? So that's kind of the basis for, I don't know what the best strategy for that would be.
All right. Nicholas, would you like to say something?
Yeah, just to add about open on demand, I think a lot of times this is probably not the best strategy, but this is what we try to do is we offer them, that we have an open on demand portal, give them a tour of how it works, and then of course on that open on demand portal there is a tab that you can open the console when you need it. So we try to give them options and show them both options, and of course always recommend them towards the one that they feel most comfortable with. But thankfully, we don't have the issue where the on-demand is not on-demand. Most of the time, people are able to get on those instances pretty quickly. Jupyter seems like it's the nicest solution for a lot of our users. They seem to really like it a lot. And then they can kind of get their feet wet as they feel comfortable by using that.
All right, David?
Yeah, I've heard of a lot of different talk about open demand or on demand. You having access to user-friendly portables, to simplify access for some of your junior faculty and maybe some of your non-experts is a plus. One thing that we've done is offer things like hybrid scheduling, to give faculty and staff kind of a mix of interactive, and resources, clear guidelines to, I guess, prevent interactive use from kind of overwhelming the system. So, simplify the access, and provide clear outlines and interactive resources for some of your new faculty and staff.
All right, Troy?
Yeah, so the way we've supported interactive use for on-demand is, well, we do a couple different things. One is we spin up lightweight desktop sessions on our Kubernetes system rather than in a batch environment. And then that runs a container that looks like the same environment as one of the clusters. The other thing we do there for more heavyweight interactive use is we have a few nodes, not a lot, usually like 2 or 4 per cluster that we call quick nodes. And these are nodes that the only thing they do is they run open on-demand desktop sessions.
Okay.
So there depending on how widely you need to scale that and what kind of resources you have, there are several different ways to come at that.
Alex?
So we use open on demand here at RCC. That is the correct question we're on right now, right? Sorry, I was responding to something in the chat. Okay, good. So yes, we use open on demand here at RCC, and we have we've noticed that is kind of the best thing for people to get started with. Trying to get new users trained to connect with SSH is very difficult and very time consuming, and we found that it really leads to frustration more than anything else. And so when a new user's coming on board and just getting started, we say, here, go to RCC, go to Open On Demand, and we have, if you're looking for MATLAB or R, Jupyter notebooks, we have all the applications set up that you might need, and we'll give them a short tutorial on how to do that, and on how to pick things correctly, and on how to upload and download files. And that, I've noticed, that'll get them about 95% of the way there. As soon as they start doing things like, hey, I need to pip install something, or I need to do install.packages in R, then we'll start to slowly introduce them to the command line. But for the most part, if they can get 95% of what they need done on Open On Demand, we will push them to Open On Demand unless there's a good reason not to.
All right. Thank you so much, Alex. Now, the next question is pretty much associated with something that Clinton mentioned before during one of the previous questions. You say, and this goes for everybody. I mean, I would like to see what you guys have experienced because every single case is different. But Clinton mentioned that we are seeing less MPI requests. So we are seeing different needs. What is the dominant need, the dominant experience, the dominant programming language, the dominant package that you guys are seeing or being used at your institution? Nicholas, go ahead.
It's a combination of PyTorch, GPUs, Python for us. There's just a high want to use machine learning training on our systems, and we only have we don't have much GPU usage resources available, so that's been a challenge for us. So
Okay.
short answer, but it's
All
easy
right.
to answer.
No problem. That is associated with AI is the trend these days. So as we have discussed, I mean, trends usually show the way, and they are going to show the need. Clinton?
Yeah, I would agree with Nicholas on that, that it's those specific, TensorFlow also. Um, and I would add to that we're, as a general statement, that data storage is the other thing. Like it's just a lot of, and not just data storage, but data movement as well. And that we're starting to see, maybe it's just our institution, but it could be with others as well. Maybe because we're in Houston, Texas, and we have the largest medical center in the country here, but we do a lot of work with med center folks. So we're getting a big influx of data, people who want to come over and use our GPUs because we have some. And so the data transfer issues, both sort of regulatory and technological limitations are things we're struggling with right now. That's a lot of thing. That's a challenge that we're having to deal with. But yeah, I would second GPUs, um, PyTorch and TensorFlow are probably the things we get asked about the most.
All right. Troy?
Uh, we're seeing the same. We brought in a new cluster last fall, and the CPUs are maybe 50, 60% utilized now. GPUs are 95% utilized all the time. The other thing we're seeing a lot of is our studio, Jupyter and Jupyter plus Spark. That's not quite as heavy as the machine learning stuff, but it is definitely up there.
All right. David? David?
Hey, some of the
Yeah.
same, just kind of, echoing some of the same.
Oh,
We look for things that are, versatile, across the field. We look for things that are, user-friendly, beginner-friendly as well. You want to, make sure that you're using, things that are popular choice, in the college curriculum as well. So, some of the same programming languages that have been shared are basically what we're using as well.
all right. Alex?
I will second and third everything Nicholas said. We've been seeing an absolute explosion in requests for things like TensorFlow, PyTorch. Python is the big one these days. Anything that has a Python backend, um, or anything in Python that has a GPU backend, we've been seeing we've been seeing explosions in that. Recently I've got one researcher that's working on an NVIDIA grant that's looking into working with the Nemo framework, and that was fun to getting that set up was fun. That was something like a 5 or 6 gigabyte Python environment. Jeez. So
All right.
yeah, Python, Python and
Okay.
GPU.
All right. So allow me to ask you this because Clinton also mentioned something associated to this, which is size, storage, or transferring of information. If a researcher comes to you and it says, well, these are my needs, I need a lot of space, what do you do to estimate the realistic needs of space for this person's project? Because one thing is what they think. I mean, we are kind of already answered that in a different scenario, but this is specifically tailored to the need of a space. I have seen cases in which they say, I need a lot of space, and then they use the storage as their own personal Google Drive. And I and there are a lot of files that are not related to a cluster. So how do you estimate the realistic needs of space for these particular researchers? What are the methodologies that you guys use to anticipate that need for space? Who wants to go first? Any volunteers?
This is a tough one. So I'll give things that we try to do. So the first thing we try to do is when we provision new HPC accounts, we ask for an estimate of anticipated storage usage. And
Okay.
usually, in my experience, it's not very accurate. It's usually underrepresented, which is a good thing, right? Because then you don't run out of
Okay.
space. But then every once in a while, you have users who are on the system for years, and their stuff accumulates, right? So we recently went through a file system reformat, and there was just data that was from when the system was first spun up like 6 years ago, and gave out emails warning about the reformat. Then the reformat came, and there was again another misunderstanding about what that storage was for. So with the reformat, we decided to actually implement a purge policy. We're hoping that doesn't create those situations where they think it's like a long-term storage solution. So I think somebody yesterday said that, oh, don't leave your gold in the trash. Someone might throw it away. And that I just wanted to repeat it because it's funny and true. So.
All right. That's a good feedback, Nicholas. Anybody else?
So we're very clear with our users about the difference between home directory storage versus project storage versus scratch storage. And home directories are really for codes or relatively small stuff. Project space is for the big stuff that you want to keep, that you want to be backed up. And scratch is intended to be very fast, but it's not going to live forever. And we've recently been running into issues with just sheer file counts. Because it used to be the problem was having enough capacity. Recently, we've seen lots of problems with people are running out of inodes just because they're using their directory structure like a database instead of like keeping it in an SQLite or HDF5 or something like that. And so we've had a couple users that came along, well, I want 100 million files. Okay.
Yeah, I would echo everything that Troy just said. Like we have the same kind of issues, and we had to put on our Scratch file system, we had to put system limits on the inode counts rather than the actual disk space quotas because of that situation. But we have many different tiers of storage with kind of different orientations, and I think one of the things we try to do is so we haven't really implemented this yet, but my boss and I have talked about having what we call kind of like a storage decision tree where we talk to the researcher and explain what these different tiers of storage do, how public are they, how accessible are they, how easy is it to move from one to the other, how ephemeral versus how permanent the storage is. And when I was talking to her about this decision tree, I said, well, I have that decision tree, but it's in my head. It's not actually written down. So one of our goals is to get that written down to help our researchers. It's not necessarily even total capacity. It's figuring out the right storage platforms for their workflows.
All right. All right. Thank you so much. All right. So let's go with the next question right here. And it says as follows. Do you ever, no, this one. How is your experience being on supporting researchers on non-local high-performance computing resources? This could be free to you, for example, resources like National Science Foundation Access, or paid resources like Google Cloud Platform or Amazon Web Services. Who would you like to go first?
I have a lot on this.
All right, go ahead, Nicholas.
So just for some background on us, about 2 years ago, our on-premise HPC went from a recharge model. So we had a lot of users not able to use our system or did not want to pay for the system. So we started looking, for solutions for them, for those users who don't have, the funds to do a chargeback model. So one of the things we started gearing towards is, making sure that users were aware of NSF access. So we made a big push on, every time I meet with a researcher and they tell me they don't have funds to do research, on a cost model. I would give them documentation on access, make an account. I can throw you trial credits because through our Campus Champions allocation, get them started on it, and then kind of show them that like it's not really that any different than using an on-premise HPC. And then on top of that, once they make their accounts, I usually would suggest to them that they make me a user, because a lot of these systems that are on Access, they give you a project directory where someone like a facilitator can, build their software and support them on anything that is not, on the system level. So that has been a success for us for getting researchers who either can't pay for on-premise HPC or their needs are higher than what we can support. So going back to the GPU example, we've had a lot of users go to Delta's system over at NCSA. So I had a user trial, hundreds of GPU hours with the A100s over there, and they were happy. So they, did the allocation, and they're working because they don't talk to me anymore, so that's good. So that's one avenue we've worked on off-premise research, and the other one we're piloting now is on Google Cloud, and we've had success with some researchers there. So, but that's still pretty much ongoing.
All right.
But the big thing there is having someone who can help architect, their solution, because you don't want them feeling like they're hung dry. Let's say they want to use a Swarm cluster, they don't do you know DevOps, to go set all that stuff up. So having a staff member who can help support them in that regard, just to get them to the where they're comfortable, is where we've seen success.
All right. David?
Yeah, one thing that we do is we have staff in place that, that allot to resource management. We want to, make sure that we're optimizing these different resource for allocation, and we're streamlining deployment for the different tools. We want to, make sure that, when you're orchestrating, you have tools that kind of help manage faculty and staff, that can scale these workloads. You want to, it's always a constant challenge, but you want to make sure that, the researchers, and the faculty staff that you have these package applications that are going to, benefit them across various systems.
All right. Anybody else? Troy, Alex?
I would second everything that y'all have said. Resource management and efficient resource management is a very difficult problem. And we try to get people to, especially with GPU resources, we try to, that's actually one good point. We've had a number of people who say, hey, I need an H500 or an H200 or a B200 or whatever the really latest super powerful thing is. And we'll say, okay, why don't you try to spin up your model on what we have right now, and then we'll look at getting a bigger node. And then they spin it up on our node, and we realize, wait a minute, you're only using 10% of the GPU. You don't need an H500. That's not going to be a good waste. That's going to be a waste of your money.
Mm-hmm.
So a lot of times we try to do little tests and little trials to make sure we'll give users a little trial period to test out their stuff, to test out their workflow on what we have and see, okay, I know you're really insistent that you need the best stuff, but do you really need it? And then we can come back to them and show them and show them like, okay, you're actually going to be fine with this.
All right. So that brings me to this question is on your personal experience at your institutions, have you actually seen a lot of scientists, researchers, faculty, students conducting research with multiple GPUs, or more of the majority of the research has involved just one GPU? Yes, go ahead, Alice.
I can give you, so we have this goes back to the cryo-electron microscopy groups. Very recent, so our big cryo-electron microscopy group we have here at FSU, they've got a little group of about 4, maybe 5 GPU nodes right now. Each of those GPU nodes has 2 GPUs each. I think they're all A4500s right now. And not too long ago they asked us to be able to changed their Slurm account configuration so they could access all of the nodes and all of the GPUs at the same time, and it was specifically to run Rely on. So this is one place where I would say if this is one place where I've noticed a lot of cryo-EM research is all GPUs all the time. And that was one example where I noticed that Rely on actually has an advantage over CryoSpark. CryoSpark has a couple of tools that can do multi GPUs, but they're limited to one node as far as I can tell. Rely on the programmer over in CryoEM was able to get Rely on just just rolling smoothly on 8 GPU cards across 4 nodes. So I've been seeing more and more multi GPU stuff. A lot of it's in cryo-EM, some of it's in AI, but AI and multi-node I haven't seen us use yet. It's mostly cryo-EM that's doing the multi-node stuff.
All right. Troy?
So we have seen Rely on scale across multiple GPU nodes. Um, we do see occasional requests for it, and we actually have a Grafana dashboard where we can feed it a job ID and we can watch what the utilization of various things on the nodes assigned to the job are. And one of the things we look for is the GPU utilization below 10% for the entire job. Because if we see that, we'll reach out to the user and say, you're probably paying a lot more for this than you ought to. You should work with us to figure out how to maybe do your job a little more efficiently.
All right.
We have seen a lot of situations where CryoSpark users they'll ask for the moon and then we'll look at what they're actually using on it. And it's like, okay, guys, you really don't need 4 GPUs and 72 cores. You can probably get by with 1 GPU and 8 cores or something like that.
Right. Right. Clinton?
Yeah, I mean, I think the level of sophistication that we're at with our GPU user community is mostly single node and in most cases single GPU. I think we anticipate more growth in, multi-node and we're planning to build out capacity to handle that. But I'm interested to see how it develops as to how many research groups will actually be able to utilize those kinds of capabilities. So yeah, I think for our experience so far has been that people are still figuring all this stuff out and just trying to get on a GPU to get their code running and and that doing things multi-node is beyond the capabilities of most of the folks working on it, at least at this time.
All right. All right. Thank you, Clinton. David?
Yeah, we're an emerging institution. Our institution is just a few years old, so we're adapting. We're a lot of single note now, but we are adapting. To things like AI, machine learning, scientific computing for various faculty members. And as student and faculty demand increases, we're increasing GPU resources and definitely expanding our GPU node offerings.
All right. Thank you, David. Thank you so much. So we're going to go for the next question, and it goes as follows. How do we balance openness, for example, research collaboration with security in shared high-performance computing infrastructures? Clinton, would you like to go first?
Sure. I think at our main high performance computing systems are all open science prepared only. Like we can't really handle regulated data in our HPC environments at this time. We do have an enclave system that's actually a Windows based, well, it's VMware based, a VDI type system that can do scientific research. Mostly it's for statistical analysis and tools like, MATLAB, R, Stata, Python coding and things like that, but does not really have the capacity to do any HPC or significant GPU. So we are in the midst of designing a successor to that system. Whether that new system is going to have HPC capacity in it, I'm not sure. But I think at least at the present time, our strategy has been to keep the worlds kind of separated from each other. We would like to be able to handle regulated data in an HPC environment. But I think we're still working to get there. So
All right. Troy?
Yeah, so we have what we call a protected data service, uh, where people can store regulated data like HIPAA data or research health information data. Um, And what we do with that is we have some special requirements on both the storage. There's a lot more access control on it, and there's auditing on file access and things like that. We also require multi-factor authentication for those users, which we don't do for the majority of our users. But that's still a work in progress for us. We're still trying to figure out how to best support these kinds of more restricted data services.
Alex, would you like to go next?
Sure. So yeah, we regulated data is a difficult problem. We have had some success with our wider central IT group using a HIPAA secure cloud solution in Azure for mostly for data storage and de-identification. Once the data gets de-identified, then we'll let it run on our systems. But it's gotta be de-identified first. Um, I haven't seen classified data or anything. Um, FERPA is another thing. I have no idea how to deal with that. So, I actually just got a request dealing with that, so I'm gonna have to be talking to my boss tomorrow morning about, oh God, what do I do?
Alrighty. David?
We touched on FERPA, and one thing that we've done is, implement, role-based access controls, and segment the data, to make sure you have authorized users can access sensitive information, but at the same time, instill, and enable collaboration, look at overall policy and monitoring, make sure you have a clear, policy for data sharing and collaboration overall, always, promote, and combine continuous monitoring, to detect, and respond to any kind of incidences that may occur.
All right. Nicholas?
So yeah, we have two separate kind of instances. So the first one is we have one group who uses export control codes on our HPC, and we primarily just control that through POSIX group permissions, and that seems to be working fine for us. And then the other instance is, well, the rest of the HPC is just like Clinton's situation. It's all open science, and there's not really much lockdown. So we couldn't do anything like FERPA or HIPAA type data. We do have a group that is outside our group working in the cloud for a secure government enclave that in AWS for QE related work, but I I think that's still a work in progress, and I think they're working on getting audited. So fingers
Alrighty.
crossed.
All
Yeah.
right. All right, so we have like 2 more minutes to go. So I'm going to propose this one. This is an easy one, maybe one for those that are starting to work in this beautiful area. Uh, how do you deal with a user or a researcher or a scientist or a student that belongs to a research group that wants to run sequential code and says that actually or claims that he needs a high performance computing cluster? Who wants to go first? Like for example, let's say a faculty member says, you know what, I am doing research in Fortran, but I need access to the high performance computing cluster because I want the code to run really fast. What is the need? What is what they actually want? How do you explain this user, hey, this is the way this should be approached? Yes, we can give you the access to the cluster because of this. How do you handle that?
The first thing I'll do is I will explain to them what precisely a supercomputer is.
Mhm.
Because a lot of times I notice that people have the 1970s idea of a supercomputer, of
Uh-huh.
this big monolithic Cray machine sitting out there somewhere. I'll explain to them the difference between that and the Beowulf clusters we have nowadays. That's sort of like that's my starting point. Always
Yeah.
that. And it's like, are you sure you need this? I also ask, like, do you do parallel computing at all? Because if you don't, this might not be that helpful.
Anybody else?
Yeah, the thing I would add is I also like to ask scale of those single core jobs because I think there is a place for high throughput computing in an HPC environment, but the scale has to make sense, right?
Yes.
So a lot of times we have researchers who run jobs, they'll run hundreds of jobs every day and they're all single core, but they run so many that they take up entire nodes. So I
Mhm.
think that use case is perfectly fine. And
Okay.
then the other one is even less so since we allow single core workflows is we make sure they don't take exclusive access of that node. We talk about the other benefits of using HPC because you can submit lots of work and then you don't have to babysit it. So I think there are use cases for it. Of course, there are systems out there that don't let you do those single core loads. If I remember correctly, tax charges by the node hour. So you got to take the whole node if you're going to use it. So
That's correct. That's correct. Well, at this point, it's 4:31, so we need to stop. I would like to say thank you to every single one of the members of the panel. Thank you so much for sharing your experiences, your point of view, your feedback, and your professionalism. Thank you so much. And last but not least, I would like to, including you, I'm going to include you on behalf of the panel and including myself, the moderator. I would like to thank Henry for providing us the space, the platform where we can share these ideas and interconnect and do networking. We can talk about this for hours. I think from the point of view, I don't know, I find it fascinating and we can talk about this for hours. So to all of you, thank you so much. To Henry, thank you so much.
Thank
And
you.
thank you all.
Thank you
Thank you.
all. Yes.
I very much appreciate your encouragement. I get to have a party with 310 of my best friends every year, and that's the best part of it. I only wish we could do it at this scale in person. That would be even more fun. I can imagine all 300 some of us going to dinner together. So let's give a big round of virtual applause to our panel and thank them for batting cleanup today. So tomorrow we will start bright and early at our regular 10 o'clock Eastern, 9 o'clock Central, 8 o'clock Mountain, and sorry, West Coast folks, 7 o'clock Pacific, and double and triple sorry to Alaska at 6 o'clock and Hawaii at 4 a.m. I'm sure they're all thoroughly angry at me about that. But I want to thank them. And our first session tomorrow will be emerging technologies. We're looking forward to that. So join us tomorrow morning. I'll stop the recording.